Okay, howdy, howdy, howdy. I'm going to give you a quick breakdown on some of this stuff right here. So let's go to here, and what we studied today. What we're studying today is XT graphs, and so XT graphs is XT. We know that the slope is meters per second, and that's going to give us velocity. Now, there's actually four different words we can get when we're talking about XT graphs, and the four words have to do with average versus instantaneous. So instantaneous versus average, and instantaneous is really the speed that you're going at that moment. And when you're looking at a graph, this slope itself can change, right? And so instantaneous means that if I have a series where I'm going to go, okay, I'm going to drive slow in the back streets, and then I'm going to drive fast on the freeway, and then I'm going to get off the exit and go slow, something like this. If this is an XT graph, my instantaneous velocity is always the slope of the line that I'm on. So at this point right here in time, I'm going that fast, that slope. At this point in time, I'm going that fast, that slope, and et cetera and so forth. Maybe at the end, I'm going to stop. And so this is flat with no slope. And so at this part here, I've got 0 meters per second. So instantaneous velocity is how fast I'm going at that moment. It's the speed that will be on your speedometer, and it's also the slope of that moment. Now, speed is a little bit different. Let's say now, let me add to this. Let's say now I drive back home. So I'm going the freeway back home, and then I go the back streets and I'm back here, right? So once again, I drove a little bit faster, but I drove negative on the freeway here. So my instantaneous velocity on my speedometer would show a faster speed. But remember, speedometer doesn't show negatives. If it's your velocity, it's going to show a negative because this is a negative slope. And then finally, when I get home, I'm sitting in my garage. So I'm in my garage here. I'm in my garage here, right? Let's just put numbers on this for distances. Let's say this first distance here is, I'm going to go up 2, right? Meters. So that's 2 meters. And then this one to here, I'm going to go up, and I'm going to go up. We'll call this, just to make this easy, we'll call this about 4 meters. And then this distance here, we'll call this another 2 meters. And then this distance here, I'm going to call this 6 meters. And this distance here, I'm going to call this 2 meters. And so this distance here is 0 meters here. I'm going up and down 0 meters. So then we got these ideas, instantaneous velocity versus instantaneous velocity versus instantaneous speed. So the only difference between instantaneous velocity and instantaneous speed is if it's speed and it's instantaneous, you can't see that. If it's speed instantaneous, you can't have a negative. If it's velocity instantaneous, you have to have a negative if it's going backwards, right? So that's actually pretty easy. Instantaneous speed, instantaneous velocity are both how fast you're moving at that moment, which would be the slope. And then, of course, if this has got a speed, and I don't know, I'll put this, maybe this is going, this section right here is down 6, and maybe that's 2 seconds, right? So there will be a negative 6 over 2, and my speed for this section would be, 6 over 2, which would give me 3 meters per second. But my velocity for this section would be equal to negative 6 over 2, which gives me a negative 3 meters per second, for example. Okay, now let's look at the little bit harder one, which is average. And so I'll choose a couple points. Like, so for instance, my average speed from here to here will be the same as my average velocity from here to here, because I'm always going in a positive direction. So I'm going 2 plus 4 is I've gone 6 plus 2 is 8. So my change in position for this one is plus 8 meters. And maybe this is, I don't know, what would this be? Maybe 10, 12, maybe 12 seconds. So maybe this whole thing would be like 12 seconds. Let's choose an easy one. Let's say it's 16 seconds, because we'd have 8 over 16 is easier. So my average velocity would be the same as my average speed. They're the same because I'm only going in a positive direction, and that would be 8 meters over 16 seconds. And that gives me 0.5 meters per second. That's easy. Average speed and average velocity, easy peasy. However, if I go from here, maybe I'll choose green. Blue. No, where's my green? I don't know where my green is. It's over there. So if I choose green and I go from here and I go to here, that spot right there, right? My average velocity is going to be that right there, just like literally that, right? So how would I get that? All right, well, that's just displacement. And so if I call this 2 meters, it's 2 meters over 16, 18 seconds, right? It's 2 meters over 18 seconds because this is a total of 18 seconds. So my average velocity for the grain would be positive 2 meters, because I've gone up from here. I've gone up 2 meters over 18 seconds. What would my average speed be for this? My average speed for this would be equal to, I went up 2, I went up 4, I went up 2 more, and then I went down 6. If I went down 6 in speed, I keep it positive. So this is going to be 2 plus 4 is 6 plus 2 is 8 plus 6 is 14 over 18. So my average speed, which you can't see anymore, would be 14 over 18, would give me whatever my average speed would be. Let's do the same one, but let's go, how is that true for velocity? It'd be plus 2, plus 4, plus 2, and it'd be minus, I said plus 4. Plus 2 for the first one, plus 4 for the second one. I said 4, but I wrote 2. Plus 2 for the third section, and then we're going to go down 6, so minus 6. So that is going to be 6 plus 2 is 8, minus 6 equals 2. And that's where I got that 2 right there. Anyways, you got 4 different things. You've got instantaneous speed and velocity, and you got average speed and velocity, and that's a couple worked examples. If you were confused today in class, maybe that will help you. All right. Email me if you have any questions. Where do my buttons go? Okay. And I am done.